Okay, number 6, pushing forward. These problems take a while, so I'm trying to save you some time. So we got 3 variables, x, y, and z, and then we got our constants. We're going to use Kramer's rule, but we're also going to try to benefit from the use of these calculators to save some time. So first thing I did is I want to find d. Remember, x equals d over, dx over d, y equals dy over d, and z, we're going to have a little fun with z, is that, if you're going to follow the formula to the nth degree, which we're not. But let's find d. How do you find d, the determinant? Well, you just take all of these coefficients, 1, 2, 4, boom, 2, negative 3, 8, boom, negative 1, 5, 3, boom, and you ignore the constants. Now to find dx, you take these constants and you replace this column with these numbers, and so on and so forth. And you do the same thing with dy. You replace the y column with your constants, and it just works. Now the goal is to find the determinant of these 3 by 3s. So let's find d. So we're going to go to math, and then we're going to go down. Where is it? I think it's right. Hold on. Whoops, my bad. We're going to go to matrix. All right, and we're going to edit, go to edit, and hit enter, and we're going to change that into a 3 by 3. And now we're going to insert our numbers. 1, enter 2. I'll pause this so you don't have to be bored by me. Okay, so I've got all these numbers inputted into my 3 by 3. Now I need to know the determinant. This is where I need to tell my calculator what to do, and this gets a little weird, but that's matrix A. Don't forget that. So I'm going to quit. Now I'm going to go back to matrix, or math. Whoops, so math, and now I want to find the, all right, I'm bumbling around with this calculator, but we're going to go to matrix, second matrix, and then we're going to go to math. So we're ignoring that math. I knew it was math, just didn't know when. So there's math. I want to find the determinant, so I'm going to select 1. And now I'm going to go to my matrices and select A, because that's my 3 by 3, and just hit enter. So I get negative 49. Sorry about bumbling, but that is negative 49. I know that's negative 49, and I know I'm going to use that, negative 49. Now I'm going to find dx. So I'm going to go ahead, back to my determinant, my matrices I mean. I'm going to go ahead and use the same one. And so here we go. Second matrix, edit, and enter. 3 by 3, pause. I'll fill in the numbers here in a second. Okay, got all my numbers input to my 3 by 3. So I'm going to go ahead and quit, which always feels funny to me. And I'm going to go to my matrix option, and I'm going to go to math. I want to take the determinant of matrix A. Enter. So this time for dx, I get 245. So I'm going to put that right here, say a little prayer, but that's divisible by 49, and it is. So I get negative 5. So x is negative 5. So one more time with dy. I'm going to show you a little trick about z in a second, but I'm going to input this information and be right back. Okay, so there's my dy, and I'm going to quit, and I'm going to tell my calculator what to do. I want to take the determinant and of my first matrix, negative 147. So negative 147. So now divided by negative 49. Should have known that. 3. Now let's use some common sense here. Could we do the same thing with z? Of course we could. But if we know x and we know y, we can just find z by using substitution, or just use that top equation there. And I'm going to plug in negative 5 for x, And then y is 3, so 3 times 2 is 6, minus z equals negative 2. That's 1 minus z equals negative 2, subtract 1, subtract 1. Negative z equals negative 3, so z equals positive 3. I'd rather do that, but you could use your calculator, probably just as fast. But there you go. So technically your answer is a point. I don't know if I shared that with you in class, but it's a three-dimensional point, which is kind of fascinating. So there it is. All right, on to letter B. Okay, the first thing I'm going to say is we're trying to mess with you a little bit as far as your organizational skills. These are all lined up, x's, y's, z's, constants. These are all just scrambled up, so you got to be careful. So I go 3, 1, negative 7, all the coefficients of my x's. Now coefficients of my y's, 1, don't have 1, that's why I put a 0, and then a 2. Then my z's, negative 5, negative 2, 15. So that's how I built it. So we're going to figure this out right now. Give me a second. Okay, so there's the matrix. And again, I'm just going to quit and clear that out. I'm going to go tell my calculator what to do. Go to math. I want to find the determinant of matrix 1. Enter. And I get a nice clean 1. That's got to make us feel good. So now we're going to find dx. That means I'm going to replace this with the constants. So here come the constants. Negative 14, negative 4, 26. From these constants right here. Okay? Okay, not boring you anymore. I just typed that in. Found the determinant to be negative 8, as you can see on my calculator. So now I know that x is actually equal to dx over d, which is negative 8 over 1, which is a nice clean negative 8. Now here's what's interesting. I already know x is negative 8, so why don't I just plug it right in there and find z, and once I know x and z I can find y without having to do all this Cramer's rule and stuff. So I'm going to pop that right in there. Negative 8 minus 2z equals negative 4. I'm going to add 8 to both sides and get 4, divide by negative 2, and I get z is negative 2. So there's my x, there's my z, and I'm going to find y. I'll just pick this top one, looks easy to me. So 3 times negative 8 is negative 24 plus y. Negative 5 times negative 2 is actually 10 equals negative 14. Well, this right here is negative 14, so if I add 14 to both sides, looks like I get y is 0. So my answer would be negative 8, 0, negative 2. Gotta believe that's the easiest, best way to do it. Okay, number 7. Find the area of a triangle with the following vertices. I've taken these points and I've plotted them right here, and you could use the distance formula. And I don't want you to write this down, but that's x2 minus x1 squared, y2 minus y1 squared, which is essentially finding the distance from here to here, here to here, here to here. And then if you know this distance, this distance, this distance, you can use the law of cosine to find the angles. And then you could use those formulas, a, b, sine of c, to figure out the area of that triangle. That is the long way. Now, we're dealing with matrices a lot, so this is a shortcut to all that craziness, and it's right here. The area formula is 1/2 the determinant of matrix A. And the determinant of A is when you have the 3 vertices, 1, 2, 3 vertices, you start with these all being 1s. Why does it work? I don't know, some of these are head scratchers. Negative 2, 4, you put the first point in that order, so it's x, y, and kind of your constant. X from here, y from there, x from there, y from there, and you got yourself a 3 by 3. Give me a second, I'll type it in my calculator. Okay, so there she is. So I'm going to quit, and now I'm going to, again, I probably am showing you too much. You're probably bored to death by this. But here we go. Just type that one in, and I get negative 61. So that equals negative 61. But I still need to take half of that. So half of that would be, should be able to do this, negative 30.5 square units if you want to get all fancy. Okay, find the area of a parallelogram with the following vertices. So we got this little picture going on. So we got that here, that here, that here, that here. This is my first point, second point, third point, fourth point. That's why I go in this order. X1, Y1, then to here counterclockwise, X2, Y2, X3, Y3, X4, Y4. That matters. So you got to stay in order there. Start with the first one, go counterclockwise. And believe it or not, you could use the distance formula from here to here. Cut this in half, distance formula, distance formula. Then you'd have this side, that side, that side. You could use law of cosine to find these angles in order to find the area of this, and then you'd have to double it. Anyways, matrices are coming to your rescue, because here's this wonderful formula, and I know it's kind of crazy, but it works. So let's take advantage of it. And that is just building a whole bunch of 2x2s between each pair of points, between x1 and y1, or x1, y1 and x2, y2, in other words, between here and here, and then between x2, y2, x3, y3, here and here, we're going to build a 2x2 with these numbers, and then between here and here, between here and here, so it completes the circuit. Now if this is a pentagon, 5-sided polygon, you could keep going, go x, well, this would be x5, y5, and then you'd have to finish it with x5, y5, x1, y1. You just keep going. But this is our problem, so let's deal with it. So I'm just going to go ahead and one at a time. I know I don't have a ton of space. There we go. Put things where they belong. So I'm going to go 1/2, and here it comes. x1 is -3. Very easy to make a mistake here. That's 2. x2 is -2. y2 is 7 plus. And now x2, -2, 7. And then x3, y3 would be 2, 4 plus. Now x3 is 2 and 4, just like this. And then x4 is 1, y4 is -1. Then we have one more, and that is this thing here, 1, and then -1, and then x1, -3, and then 2. Boy, that is quite a mental juggernaut. Well, this is -21 minus a -4. So it's -21 plus 4, which is -17. I'll deal with that 1/2 later, last. This is -8 minus 14, which is -22. This is -2 minus 4, which is -6. So you're getting a, I think I remember something. It's all coming back to me. And then 2 minus, that's a +3. So it's 2 minus 3, which is -1. So a little PEMDAS. So the question is, how can you have a negative area? We'll get to that in a minute. Well, this is -39, -45, -50. Now, when dealing with areas and determinants, give me a second here. Okay, so 1/2 of -50 would be -25. Now here's my curiosity. If we were to go from here to here, here, here to here, here, here to here, here, here to here, here, I'm going to gamble and say we're going to get a +50. So if you get a negative value here, it kind of serves two purposes. This determinant looking thing, you would also take the absolute value of it. So it'd actually be +25 because you can't have a negative area. I'm glad I stumbled upon that. just FYI. Alright, here we go, just pure matrix stuff. A times B. Well, because it's sitting right there, we can go ahead and just use it. So that means multiply the first row of A times the first column of B. Notice we got 3 elements here and 3 elements here. That means we're good to go. And that's going to go in the upper left-hand corner. That's just the way it is. 6 times 0 is 0. 2 times 1 is 2. Plus 0 gives us a 2. And then we just keep throwing that thing through columns until the columns in this second matrix disappear. And then we're going to put that in the upper right hand. So 6 times this is negative 24, plus 0, plus 0, negative 24. And now we're done with this row. We're going to go to that row through that column and put that answer here. 5 times 0 is 0, 0, plus 1. Those zeros are nice. Now this row is going to go through this column, and that's going to end up here. So that's negative 20 plus 0 plus negative 3. That'd be negative 23. And there it is. A times C. Well, if you notice, this has 3 elements. This has 2 elements. That is not possible. Can't do it. Now the inverse of any matrix 2 by 2 has a little formula, and that is 1 over the determinant of that matrix. Give me 1 second. Okay, so here we go. We've got the formula now. Now if the normal matrix C equals this 2 by 2, then the inverse tells us to flip those. So let's go ahead and do that. Let's follow this formula. So, well, we'll start here. What's the determinant of matrix C? Well, that's 2 minus 0, which would just be 2 or 1/2. But now we have to follow these rules. So we flip these two, so that's going to be a 1 and a 2. These, you don't flip them, you just take the opposite. The opposite of 0 is just 0, and then the opposite of negative 3 is just 3. Now, a lot of people habitually want to multiply this and multiply that and find the determinant. That's not what we're doing. Now we have to distribute that to all 4 of these little elements. So we get 1/2, 0, 3/2, and 1. Done. All right. I'm going to finish these last two, or last one. A times B, which we already calculated. So let's go ahead and steal that. Minus C, which is 2, 0, negative 3, 1. You just have to protect yourself from a silly mistake. So item by item, 2 minus 2, 0. Negative 24 minus 0, negative 24. 1 minus a negative 3, 4. Negative 23 minus 1, negative 24, and that would be it. That finishes this video. Like and subscribe.